All right, let's look at example 3. So what we're going to do here is prove that polygons with given vertices are congruent. Okay, so we have the vertices A, B, and C here. And then we have the vertices P, Q, R, which are here. So this is what our pre-image is. And something's happening to transform into this image. But we want to see, are they congruent? And remember, for them to be congruent, it has to either be a reflection, rotation, or a translation. So does this look like it would be a reflection? Does it look like it would be a rotation? Does it look like it would be a translation? Well, if you look at the way this shape is oriented, it's not in this the same like orientation. Like this is the B is pointing down. You know, it's kind of like an arrow pointing down a little bit, and that's not the case here. So the orientation is different. So that means if it's a translation, right? That means that it's always going to be, you know, kind of like this, right? But when it starts to change its orientation, like the way, that means it's either a rotation or it can be a, oops, sorry about that. It could be a reflection, right? So it's either one of those. This doesn't look like it's reflected over the x-axis and doesn't look like it's reflected over the y-axis. So I would say that this is probably a rotation. Since it's going from here and in this direction, I would probably say it would be a counterclockwise rotation. So let's go ahead. Do you guys remember what that rule is for the counterclockwise rotation? Let's see. The rule for the counterclockwise rotation, x, y goes to, remember the x and the y, they rotate spots, but the y is negative. So we think maybe it's a counterclockwise rotation. So let's just go triangle ABC is mapped to triangle PQR by a counterclockwise rotation, or the y and the x switch spots, but the y is negative. So let's go ahead and apply that to all these points. So we start with A, right? And then we apply this rotation, and what happens? We end up with, okay, the 2 and the 1 switch spots, except the y is negative. So negative 2, 1. Negative 2, 1 would be right here. And that would be, oh, it doesn't map onto these. This would be A prime. Okay, let's do the same thing for B. B is at 2, 1. And then a counterclockwise rotation, we would switch the spots, and then that y becomes negative. So B ends up being negative 1 up 2, 1, 2 here. So this is B prime. And then C is 4, 2. And, okay, so the 2 and the 4, the x and the y switch spots, and then the y is negative. So that would be negative 2 up 4. 1, 2, 3, 4. Huh, interesting. So here is our 90-degree counterclockwise rotation. But you see, it's still not in the same spot. You see that? So it's rotating, but what else? It's rotating, and then what does it look like from here to down to here? Well, it seems like it's staying kind of in the same position. It's just shifting down. So what we end up having is a rotation, a counterclockwise rotation, and then we have a translation that's shifting us down how many? So from A prime to P, so it's to the left 1 and down 1, 2, 3. Okay, is that the same for B? Okay, to the left 1 and down 1, 2, 3. Oh, that worked. And is it the same thing here? to the left 1 and down 1, 2, 3. And it is, so that rule works for all 3 vertices, so therefore it is a translation. So what this means is that when you're trying to tell whether figures are congruent or not, we said, okay, if it is an isometry, which is a translation, reflection, rotation, right? But it can also be congruent if it's any combination of a reflection, rotation, congruent, right? So if a figure is reflected, well, it's still congruent. And then if it's rotated, well, it's still congruent. And if it's translated, it's still congruent. So you could do either of those multiple times, many, many times, and no matter how you rotate and rotate and translate and reflect it and all those types of things, as long as those are the only 3 things that are happening, from the beginning to the end, you're still going to have a shape that is congruent. So with example 3, you're going to be looking at trying to find if something's congruent when you're dealing with multiple transformations. And if you can show that there are multiple transformations which are isometric, right, which are the translations, reflections, and rotations, then you can prove that those 2 triangles are congruent, which is just the whole point of this entire chapter. It's proving triangles are congruent. So this is how we're doing it. We're proving triangles are congruent through multiple transformations or multiple isometries. Okay, perfect. So now we just need to write it all down. So what we're going to say is that triangle ABC can be mapped to triangle A prime, B prime, C prime, which is what we have here, right? By a counterclockwise (90-degree) rotation, which is the rule XY goes to, right, the Y and the X switch, but the Y is negative. That's counterclockwise. And then, so we had the rotation, and then we have A prime triangle, A prime, B prime, C prime. This is where we're starting. Can be mapped. Mapped kind of means like can be moved. So it can be mapped, it can be moved to this triangle, to triangle PQR by a translation of XY goes to, the X goes in the negative direction 1, so X minus 1, and then it goes down, what do we say, over 1, down, what was it, 1, 2, 3? Yeah, so Y negative 3. And there you have it. There is our proof. It's kind of like a little paragraph type proof. But that is how we are going to prove it for these types of examples. All right, let's go ahead and look at the next example, and we'll go ahead and work on this one together. So it says, prove that the polygons with the given vertices are congruent. Okay, so we're going to start here with A being negative 4, 2, 1, 2, 3, 4, up, no, negative 2. 1, 2, right here, negative 4, negative 2, okay. A, all right, and then B, negative 2, 1, right here. C is 2, negative 2 here. Okay, so we start here, and then we end up with a figure that looks like this. P is 1, 0, so that's P. Q is 3, 1, 2, 3, negative 3, 1, 2, 3 here. Q. And R is 3, 1, 2, 3, 0. Okay. So this is the figure that we come up with, right? Probably should have made that line like that. Okay, so what is happening here? You know, if we look at the shapes of these, are they in the same direction? It doesn't look like it, right? It looks like this one is pointing up here and now it's pointing down, which would show that it actually is a, what do you think? A translation, reflection, or rotation? Well, if it's pointing up and then now it's pointing down, that would definitely be a reflection, or that might be the first piece of it. So I always like, whenever I'm doing these and there's multiple transformations happening, I like to do the ones where it changes the shape. So like up here, I like to get the shape like so it's like in the same position. I mean, not the same, but it's kind of in the same position. That's what I like to do first. Because right now it's just not even in the right position here. So that's the same thing here. So I can tell that this is pointing down and this is pointing up. And when that's happening, we know that it's reflection. So I want to go ahead and reflect it first. And then from there, I can easily do the translation, which will probably be the case. So let's go ahead and reflect this. So we start here. And we're going to go ahead and reflect it, right? So do you remember what this is going to be reflected? So for here, right, then this is going to be 2 away from, probably going to be reflecting it over the, probably the, I would say the x-axis. So then it would be pointing down. So if I reflect it across the x-axis, this is down 2, so then it's going to be up 2. Well, what are we talking about? We're talking about the x is staying the same, right? The x is 1, 2, 3, -4. But what's changing? The y part, right? It's negative, and then we're going to reflect it across this x-axis, which then would make it a positive y part. So that we know that the rule is for this is going to be it's going to be x, y goes to x, and then the y is going to change, so it's going to be -y, right? So let's go ahead and figure out what those points are. So here A is -4, -2, and then we're going to call that, it's going to go to A prime, which means the x stays the same, -4, and then the y changes. So this is a -2, so it's going to be a +2. So if you look here, I'll use a different color. Let's see here. So -4, 1, 2, 3, 4, and then up to 1, 2 would be right here. Okay, so that's going to be A prime. And then B is also going to reflect. And B is -2, 1. And that's going to go to B prime, which would then, the x stays the same, and then the y becomes negative. Okay, so -2 down 1 would be here, B prime. And then lastly, C is going to, what's C start with? 2, -2, and then it's going to become C prime, where the x stays the same, and then the y becomes negative. This is -2, so then it's going to be a negative times a negative, which is a positive. So it's going to be 2, 2. Wait, is that right? That's not right. 2, 2, 2, -2, 2, would be 1, 2, -2 would be all the way over here. Oh no, did I totally mess this up? How did I mess it up here? 1, 0, 1, 2, 3, -3, 3, -3, and then R would be 3, 0. How did I mess that up? Okay, so this, I don't know why this is supposed to be -2, -2C. -2, -2. It's not supposed to be 2, -2, -2. No, that wouldn't even give you a congruent figure. Yeah. So that's a typo. There's supposed to be a negative right here. So go ahead and put that in your notes. Okay. So we're supposed to start with -2, -2. And then what happens? The x stays the same. So -2, and then this is a -2, and then it becomes a positive. So -2, -1, -2, up 2. Sorry if you guys were confused by my graphing. C prime. So yeah. So this is the figure here. So it is now reflected across the x-axis. Okay? And then we just need to talk about this translation, right? Because it's just from here to here, it's a shift. So how much is it shifting? So from B to Q, what's happening? It's shifting to the right, so that's in the positive direction, horizontal shift. That would be 1, 2, 3, 4, 5, and then down 1, 2. So let's see if that's the same case here. So let's go from A to P. 1, 2, 3, 4, 5, down 2. That's the same thing. That's the same rule. Let's try it from C prime to R. 1, 2, 3, 4, 5, down 1, 2. So since that is the same rule for every single vertice that corresponds with the other, then we know that this is a translation. So since we have a reflection and a translation, both of those things are isometry. So we know, therefore, these triangles are congruent. So now we just need to go ahead and write it all out. So we start here, and we could say that triangle ABC is mapped to triangle A prime, B prime, C prime by a reflection across the x-axis, which is x, y goes to x negative y, okay? And then a translation, I should say this. Triangle A prime, B prime, C prime is mapped to, and map to is just kind of like moves to, so like ABC moves to A prime, B prime, C prime. By, how is it moving? It's moving by a reflection across the x-axis, and this is the rule. And then A prime, B prime, C prime moves, but they like to use the word is map to, is moved to triangle PQR by a translation. So triangle A prime, B prime, C prime is mapped to triangle PQR by a translation. X, Y goes to X, and what happened with the X? It went over in the positive direction 1, 2, 3, 4, 5 times, so X plus 5. And then what happened? Y, it went over 5 here, and then it went down 1, 2. So that would be Y minus 2. So that would be the proof showing that these two triangles are congruent. It did a reflection, and then it did a translation, which are both isometries. So whenever you work with any type of isometries, rotations, reflections, and translations, any combination of those will still give you a figure that is congruent. The image will be congruent to the pre-image. All right, so, a helpful hint, translations, reflections, rotations can be called congruence transformations. So those are congruent because no matter whenever you do that, you still, whatever you start with and whatever you end up with, those pictures, those images are the same. They are congruent. The start and the end, whenever something's rotated, reflected, translated, or any combination of those three with multiple transformations, they are called congruence transformations. Do you remember which is the only one that's not? And that is a dilation. Dilations, remember, you have something and it gets smaller, or you have something and it gets even bigger. So that's a dilation, which is not congruent. The size is changing. So yeah, so that's it for this lesson. I will see you next time for the next lesson.